area of a triangle, it's half base times height. Or altitude of a triangle is always relative to a chosen base. You choose your what? Your base. It's up to you because the triangle has got 3 sides. So you decide which base you want. Then from that base, you can then determine your height. Okay? So you've got these 4 triangles. Okay? Their orientations are different. For the first one, if you choose BC to be your base, it means your height is going to be from A up to that point. Okay, and obviously remember the height is perpendicular to the base. Okay, then for the next triangle, if you choose AC to be your base, it means your height is going to be from B to that point. Okay, for the third one, if you choose AB to be your base, your height will be from here to there. Now the third one, this one here is a unique triangle. If you choose this one to be your base, your height is going to be the perpendicular line drawn from vertex A up to a line produced from point B, so that you can end up having from here to there as your height. So always when you want to determine the area of a triangle, you have to choose your base first, and then you can determine your height. Okay, so that's the first key concept on triangle geometry. Then the next one, this one is new now. Okay, the first one, obviously you know it was for the previous grade, but it's very important for you to know that if you want to determine the area of a triangle, you choose the base first, then you determine your height. Now the next one, 2 triangles which share a common vertex have the same height. Okay, if 2 triangles share a common vertex, then you can conclude that they have the same height. Now this concept of geometry of triangles is very, very important. Okay, there are 3 that we'll talk about, but number 2 is very important. You are going to realize it later when you start doing problems on the proportion theorem. If you forget this one here, you might have a problem with the question. So, if you are given a triangle, okay, here you have got triangle, okay, there are 3 triangles, right? You've got ABD, you have got ACD, and you've got ABC. There are 3 triangles, okay? Now, those 3 triangles, they have the same height because the 3 of them share a common vertex, and that vertex is vertex A. If triangles share a common vertex, then you can conclude that, okay, their heights are the same. Okay, so point A is what? Or you can say vertex A is a common vertex for all 3 triangles. Okay, just to remind you, here we have triangle ABC. We also have triangle ACD. And we have triangle ABD. Those are the 3 triangles we have. Now you can see that A is appearing in all their names. We've got that A there. Okay, that A is our common vertex. Okay, as long as triangles share a common vertex, you can conclude that therefore their heights are the same. Okay, so you can end up writing the formula like that. And then now, once the height is a common height, okay, it's also very important for you to know that the ratio of their areas, okay, the ratio of their areas will be equal to the ratio of their bases. So if I divide, say, the area of triangle ABC with the area of triangle ACD, I'm sure you can see that area of triangle ABC is going to be equal to half times BC times H. The area of triangle ACD is going to be equal to a half times CD times H. Any two triangles that share a common height, okay, if you want to determine the ratio of their areas, it will be equivalent to the ratio of their bases. So, from your knowledge of solving, this cancels with that, the h cancels. So, the ratio of their areas will be equal to the ratio of their bases. Okay. But for you to be able to come to this conclusion, you need to start by identifying a common vertex. Okay? So let's move on to the next one. Okay, so I spoke about this triangle. The same concept applies here, right? There is a common vertex there for all three triangles. And our three triangles are going to be EDF, we have got EFG, and we also have EDG. There are three triangles, and they share a common vertex. Therefore, their heights or their altitudes are the same. Hence, the ratio of their areas will be equivalent to the ratio of their bases. Right. What I want you to do was, what I just said is very important. Okay, you need to write it down somewhere. That if triangles share a common vertex, okay, it means that they have a common height. Therefore, the ratio of their areas will be equivalent to the ratio of their bases. Please write it down somewhere because it's not there. If triangles, if at least any two triangles or three triangles have there a common vertex, it means that they have the same height or altitude. Therefore, the ratio of their areas will be equal to the ratio of their bases. That concept, you are going to encounter lots of questions where you need to know that. Okay. So it's more like there are actually 4 points that you need to know, right? So the one for areas I have included under part B on the vertex. Then the fourth one, remember I'm saying the fourth one goes there, the third one is not there. All right, triangles with equal or common bases lying between any two parallel lines, okay, have the same area. So if you have got two parallel lines and you draw two triangles inside those parallel lines, okay, you can make a conclusion that since they are going to be sharing a common height, because remember, if you draw them between parallel lines, it means they are going to share a common vertex. Okay. Therefore, or you can say, since they are going to have a common height, it therefore means that they have the same area. Okay, like here, if you look at triangle ABC, that is ABC. Okay, and then you look at triangle D, you can call it DCB. This is a common vertex for all three. This one, for those two. It will be a common what? Vertex. And that vertex, I hope you can appreciate that you can identify it. Okay, we have got that B there. And this is also a common vertex. So you've got two common vertices there. Okay? So as long as triangles share a common vertex, any two triangles, it therefore means that their height is the same. Therefore, you can say that the ratio of the areas will be equal to the ratio of their bases. But if the two triangles are drawn between two parallel lines, if they share a common base, and we know that their height is the same, it means their areas will be equal. Okay, so these two triangles, that is triangle ABC and DBC, they have two things that are important when it comes to the area of a triangle. Their height is the same, their base is the same, therefore their areas are equal. Therefore, the ratio of their areas will be equal to 1. Okay? So it also applies to the next diagram. Okay, so we have got EFG, EFG, and HGE. They share a common vertex there, they share a common vertex there. And this E there, and that E, the sign, and that H, and that H. I mean, they share two vertices. Okay, yes?
So, you see the center where the line cross over?
Yeah.
So
you're talking about this point?
Yes, sir. So if you have to add a point there, and they have the same vertex with the ratio of the bases be equal to the ratio of the area.
Alright. You need to be very careful there. If you add a point here, maybe you can call it what? Whichever, maybe M. Which two triangles are equal? Because you have to identify the two triangles.
ABM and DCM.
ABM and DCM. Okay, you cannot make that conclusion. Okay? Because first thing, if you look at it, we can't say the height of both triangles is gonna be H, because we need to identify a base first. Remember the first concept. The height of or altitude of any triangle is chosen relative to you choose it you determine it based on a chosen base. So those two, we cannot make a conclusion that they have got the same height. Okay? Alright. Another question? Okay. So I hope you're okay now. So let's alright. Consider a line segment AB. If AB is 35 centimeters, okay, let's put an equal sign. AB is equal to 35 centimeters, and okay, it's 35 centimeters, and point C divides AB in the ratio. Okay, let's call it AC is to CB in the ratio AP is to CB as equal to say 4 is to 3.
I'm sorry to trouble everybody. Please can the educator that has Sinagugu Sitore in class with them now.
You have so far. Okay? We can calculate the length of AC. Right? If I want to calculate AC, I'll say AC is equal to, right, based on the ratio, your denominator of the factor will be 4 plus 3, which is 7. So that will be 4 over 7 times 35, and you get 20 centimeters. Okay? For BC, okay, for BC or CB, you can say 3 over 7 times 35, or you can just subtract the 20 from 35. So we know that BC is going to be 15 centimeters. Because it's equal to 35 minus what? 20. Okay. Now I want you to know that we can also determine these lengths by using a constant together with the ratio. Okay, we can also determine these two lengths by using the ratio that we are given together with a constant. That constant is such that if I multiply this 4 by it, I'll get the 20. If I multiply the 3 by it, I'll get the 50. And I'm sure you can guess what that constant is. Okay? But in most cases, in all the questions that you are going to encounter, you won't be given a value for that constant. Okay? Generally, that constant, we call it K. So if I divide the same length, remember our ratio is 4:3, so I can divide it into 7 equal parts. Okay? I don't have a ruler, so here with me there, so that's 3, then 4, 5. Okay, remember we have point A here. Our point C is going to be the with a different color. So our point C will be here, point A is there, and point B is there. And we know that the total length is 35 centimeters. Okay, let me call each division, let me call it K. But you can, it's up to you, you can call it Y. You can call it Y, or you can call it what? K, or any other letter. So for our lesson, I'll call that one K, that one K, that one K, okay, like that. So that AC in terms of K will be equal to 4K. Then CB will be equal to 3K. Okay. So if I want to determine those lengths in terms of K, my AC will be equal to, that will give me 4K over 7K times 35. The good thing is that the K cancels out and you still get your 20. Alright? Your CB, if you do the same, you get 3K over 7K times 35, and you get 15 centimeters. Okay? Please, when you are given a ratio, that's not the length. Okay? So, the 4, if you are given, in this case, if you have got AC to CB, it's equal to 4:3. It doesn't mean that AC is going to be 4 centimeters or 4 units. And it doesn't mean that CB is going to be equal to 3 centimeters or 3 units. It's a ratio. To determine the actual length, you need to multiply each value in the ratio by the same constant. And that constant, you can call it K, you can call it what? Y. Now, we can determine that constant. So that constant, you can say 7K is going to be equal to 30 what? 35. And you get K equal to 5. Okay. So if I want to get the original length for AC, I just have to multiply this 4 by 5. I'll get 20. This 3 by 5. I'll get 15. Okay. Now in your case, in terms of your proportion theorem, the question that you are going to encounter, you are going to need to know the concept of that K. Okay, I'll remind you later on. Any question there?